Question 8. Is the proportion of marshmallows in Mr. Miller's favorite breakfast cereal lower than it used to be? To determine this, you test the hypotheses H0, P old equals P new, HA, P old greater than P new, at the alpha equals 0.05 level. You calculate a test statistic of 1.980. Which of the following is the appropriate p-value and conclusion for your test? Okay, so we already have the test statistic, which, remember, this is a z-score. So to get the p-value, we're going to draw a standardized normal distribution, mean 0, SD1. Okay. Use the test statistic as our boundary value. So 1.980, we'll just say 1.98 right there. And then shade the tail that matches the direction of the alternative hypothesis, right? So the alternative hypothesis has a greater than sign, so we're going to use the right tail here for the p-value. Okay. So I'm just going to use my calculator, although you could use table A. So I'm just going to use normal CDF. So second vars, normal CDF, lower bound 1.98, upper bound 99999, mean 0, SD1, and we get that the p-value is 0.0239. Okay, so we can eliminate choice A and B because those don't have the correct p-value. Okay, C, D, and E all do. Okay, now this p-value is smaller than our significance level. Okay, so because this is less than 0.05, it means the result is statistically significant, which means we should reject the null hypothesis and conclude that we have convincing evidence for the alternative. Now in context, we are going to say we have convincing evidence that the proportion of marshmallows in the old cereal is greater than the proportion of marshmallows in the new cereal. Or to phrase it another way, that the proportion of marshmallows is now lower than it used to be. Okay, so C says fail to reject the null hypothesis. That's incorrect. E also says fail to reject the null hypothesis, so that would be incorrect. So I guess it's D. Okay, reject the null hypothesis. We have convincing evidence that the proportion of marshmallows has been reduced. Yes.